Hello, and welcome to this brief presentation on algebraic fractions. Algebraic fractions. Algebraic fractions can be added, subtracted, multiplied, and divided in the same way as numerical fractions. Within this presentation, we will review how to add, subtract, multiply, and divide numerical fractions and apply those methods to the algebraic fractions. This presentation assumes that you understand the terminology for a fraction, that the top line is called the numerator and the bottom line is called the denominator. We will use this terminology throughout the presentation. The example below, for the shaded number of parts in the circle, this is 3 upon 4, numerator is 3 and denominator is 4. Addition of fractions. To add two fractions together, we need to find a common denominator. This can be found by multiplying the two denominators together. So in question 1 here, we have a half, 1 divided by 2, plus the third, the 1 divided by 3. The common denominator for 2 and 3 is 6. If we multiply the 2 by the 3, we get the common denominator of 6. We then say, how many times does 2 divide into 6? It goes 3 times. So we multiply the 1 in the numerator by 3. We then say, how many times does the 3 divide into the 6? That goes twice. So we multiply by 2. Simply applying our BODMAS on the top line, we end up with 3 plus 2 divided by 6. That simplifies to 5 upon 6. In question 2, we're asked to add 2/5 to 9/10. Again, we could find a common denominator by multiplying the 5 by the 10 to get 50, but that wouldn't be the lowest common denominator. So if we can realise that 5 and 10 divide completely into 10, 10 is the lowest common denominator. What we now say is, how many times does 5 divide into 10? It goes twice, so we get 2 multiplied by 2 for the numerator. And how many times does 10 divide into 10? That goes once, so it's 1 times 9 in the numerator. Now applying BODMAS on the top line, 2 times 2 is 4, plus the 1 times 9 is 9, so that adds up to 13 upon 10. Question 3, we're adding 3/4 to 3/8. Find a common denominator. We could multiply the 4 by the 8 to get 32, but the lowest common denominator that 4 and 8 divide into is 8. Again, we say, how many times does 4 divide into 8? It goes twice, so we multiply the numerator by 2, so it's 2 times 3. And how many times does 8 divide into 8? That goes once, so we multiply the numerator by 1. Evaluating the top, we get 6 plus 3, that becomes 9 upon 8. And finally, question 4. We're asked to add 3/10 to 1/4. We could use 10 times 4, i.e. 40, as a denominator, but the lowest common denominator that 10 and 4 completely divide into is 20. So repeating our process, how many times does 10 divide into 20? It goes twice, so that's 2 times 3 in the numerator. And how many times does 4 divide into 20? That goes 5 times, so that's 5 times 1 in the numerator. Evaluating, we get 6 plus 5 in the numerator, that's equal to 11 upon 20. So that's how we add fractions using numerical values. So adding algebraic fractions. If we're given the fraction a upon b added to c upon d, that will actually be evaluated as a multiplied by the d plus b multiplied by the c in the numerator, or divided by b multiplied by d in the denominator. Let's look at that in example 1. We've got x upon 2 added to y upon 5. To find the common denominator, we simply multiply the denominators together, so 2 times 5 here will give us 10 as a denominator. We now say, how many times does 2 divide into 2 times 5? It goes 5 times, so it'll be 5 times x in the numerator. And how many times does 5 divide into 2 times 5? That goes twice, so that's 2 times the y in the numerator. Just tidying that up on the following line, we get 5x plus 2y divided by 10. Example 2, we're asked to add x plus 4 divided by 3 to x minus 3 divided by 4. It sometimes helps thinking of the numerators in terms of brackets. So I'm going to add the brackets here just to show you what I mean. Again, to find the common denominator, we simply multiply the 3 by the 4, and that gives a value of 12. We now say how many times does 3 divide into the 3 times 4, the 12? That goes 4 times. So multiply the numerator by 4. How many times does 4 divide into the 3 times 4? That's 3 times. So multiply the numerator by 3. And again, notice we've used brackets around the x plus 4 and the x minus 3. We must have the brackets there. Expanded on the next line, x plus 4 multiplied by 4 becomes 4x plus 16, and then 3 multiplied by the x minus 3 becomes 3x minus 9. What we're doing here is expanding the brackets like this in both cases. Collecting our like terms in the numerator, 4x plus 3x is 7x, and 16 minus 9 is plus 7. That's all divided by 12. So there's our solution. Subtraction of fractions. This is an almost identical process to that of addition of fractions. Question 1. We're asked to calculate a half minus 1 upon 3. Exactly the same process. We need a common denominator. Common denominator of 2 and 3 is 6. How many times does 2 divide into 6? It goes 3 times. So that's 3 times 1 in the numerator. How many times does 3 divide into 6? That's 2. So that's 2 times 1 in the numerator. But notice this time we are subtracting the values. So from BODMAS on the top line, that will be 3 minus 2 divided by 6, or 1 upon 6. Question 2, we're asked to calculate 1 upon 3 minus 1 upon 5. Common denominator for 3 and 5 is 15. 3 times 5 is 15. How many times does 3 divide into 15? That's 5 times, so that's 5 times 1 in the numerator. And how many times does 5 divide into 15? That's 3, so that's 3 times 1 in the numerator. Again, we are subtracting these fractions, so undertaking the arithmetic, that is 5 minus 3 in the numerator divided by 15, or 2 upon 15. Question 3, we're given 2 upon 3 minus 1 upon 2. Again, the common denominator for 3 and 2 is 6. And we repeat the process. How many times does 3 divide into 6? That's 2. So that's 2 times 2 in the numerator. How many times does 2 divide into 6? That's 3. So that's 3 times 1 in the numerator. And again, we are subtracting the values. Looking at the arithmetic, that becomes 4 minus 3 on the top line. So 1 upon 6 is our solution. And finally, question 4. We're asked to calculate 7 upon 8 minus 3 upon 8. Now, because the denominators in this case are already the same, they're both 8, we simply subtract the numerator. So it's simply 7 minus 3. So that's 4 upon 8, which cancels to 1 upon a half. So that's how we undertake subtraction of fractions using numerical values. Let's consider subtraction of algebraic fractions. If we're given fractions of a upon b minus c upon d, the solution will be of the form a multiplied by d minus b multiplied by c, or divided by the denominator b multiplied by d. Let's look at example 3 here. We're given a fraction of x plus 2 divided by x minus x divided by x minus 2. Again, it can help the solution to think of the top and the bottom being in terms of brackets. So the common denominator for x and x minus 2 in the brackets is x multiplied by x minus 2. You must have the bracket there. So our process is to say how many times does x divide into x multiplied by x minus 2? It goes x minus 2 times. So we multiply the x plus 2 by the x minus 2. Repeat the process. How many times does x minus 2 divide into x multiplied by x minus 2? It goes x times. So we multiply the x by x. So now we're going to take our bracket expansion on the top line. So that will be x multiplied by x is x squared. X multiplied by negative 2, so that's negative 2x. then we get positive 2 multiplied by x, so that's positive 2x, so that cancels with the negative 2x. And finally we get positive 2 multiplied by negative 2, so that will be negative 2 squared, or 4. So on the next line, I've got x squared minus 2 squared, which is really 4, minus the x multiplied by the x times x, all divided by x squared minus 2x. And again, we have expanded the bracket on the bottom line. So on the final line, we're going to add our like terms together. So notice in this particular case, we've got an x squared minus an x squared, so they cancel. That leaves us with simply negative 2 squared, or negative 4 on the top line, and on the bottom line we've got x squared minus 2x. Multiplication of fractions. Question 1. We're asked to multiply 2/3 by 4/5. With multiplication, the first thing we try and do is look for simplification by cancelling down where that's appropriate in the problem. If we cannot cancel down, then all we do in multiplication is multiply the numerators together. So in this case, that's 2 multiplied by 4 is 8, and multiply denominators together. That's 3 multiplied by 5 is 15. In question 2, we're asked to multiply 3/4 by 5/7. There's no cancelling down again, top or bottom here, so we're simply going to multiply numerators, multiply denominators. So 3 multiplied by 5 is 15, and 4 multiplied by 7 is 28. In question 3, we're asked to multiply 13 upon 8, multiplied by 7 upon 26. This time, I do have some cancelling. Can you see that the 13 and the 26 cancels to produce 1, 2. So now my problem has simplified to 1 upon 8 multiplied by 7 upon 2. That cannot be simplified any further. So now I multiply my numerators and multiply my denominators. So for the numerators, 1 times 7 is 7, and denominators, 8 times 2 is 16. Question 4, we're asked to multiply 3 fractions together. We've got 3 upon 2 multiplied by 2 upon 5 multiplied by 5 upon 2. Again, we look for cancelling down if that occurs, and I can see some cancelling here. The 2 with the 2 goes to 1 and 1, and the 5 with the 5 again goes to 1 and 1. So the calculation now simplifies to 3 upon 1 multiplied by 1 upon 1 multiplied by 1 upon 2. Multiply my numerators together, I get 3. Multiply my denominators together, I get 2. Multiplying algebraic fractions. So if we're multiplying a upon b by c upon d, then we simply multiply a by c and b by d. Example 4, we're given 6x divided by x minus 2, and that's multiplied by x divided by 4. Where possible, we always look for cancelling down, and there is some slight cancelling here. The 6 and the 4 cancels to 3 and 2. So my calculation now is 3x upon x minus 2 multiplied by x upon 2. I now multiply my numerators together and multiply my denominators. So 3x multiplied by x is 3x squared, and x minus 2 in brackets multiplied by 2 can be written as 2 multiplied by x minus 2. And I could, if I wanted to, go into decimals. 3 divided by 2 is 1.5, so I could write it as 1.5x squared upon x minus 2. But either solution here or here is acceptable. We're now going to consider a brief proof as to how to divide fractions. Supposing I'm given the fraction of a upon b, which is divided by c upon d. I could write that as a upon b, all divided by c upon d. It's the same fraction, same calculation. If I now multiply the top fraction by the denominators b and d, and multiply the bottom fraction by the same denominators b and d, I do not affect the fraction. That's rather like multiplying the top by 2 and the bottom by 2. I don't affect the overall fraction, I just factor the fraction up. What we notice is that on the top line, the b cancels with the b, and on the bottom line, the d cancels with the d. I can then rewrite the fraction as a multiplied by d on the top line, and on the bottom line as c multiplied by b. If I now just slightly rearrange that, I can write that as a divided by b multiplied by d divided by c. When we now consider what we started with, the a upon b divided by the c upon d, and what we've ended up with, the a upon b multiplied by the d upon c, we can see that the first fraction is the same, a upon b. The second fraction has been flipped. The c upon d initially becomes now d upon c, and there is a sign change between the fractions. Some students refer to this as the Kentucky Fried Chicken method. In other words, we keep the first fraction, we flip the second fraction, and we change the sign between them. If the KFC method helps you remember how to undertake division of fractions, then please apply it, but the proof is shown above. Let's now consider division of fractions using numerical values. Question 1, we've got 4 upon 5 divided by 4 upon 3. Applying the technique on the previous slide, we keep the first fraction, so 4 upon 5, we flip the second fraction, so that becomes 3 upon 4, and we change the sign. Once we have the fraction in the form of multiplication, we look for cancelling down, and there is some cancelling. The 4 on the top cancels with the 4 on the bottom, goes to 1 in 1. So our calculation simplifies to 1 upon 5 multiplied by 3 upon 1, which gives us 3 upon 5. So question 2, we have 2 divided by 1 upon 4. So we keep the first fraction, which is 2 upon 1. We flip the second fraction, so that now becomes 4 upon 1, and we change the sign. Evaluating 2 multiplied by 4 is 8. Question 3, we've got 5 upon 8 divided by 15 upon 32. Again, keeping the first fraction, 5 upon 8. We flip the second one, so that becomes 32 upon 15, and we change the sign. In looking for cancelling, the 5 and the 15 cancels to 1 and 3, and the 8 and the 32 cancels to 1 and 4. So the problem simplifies to 1 upon 1 multiplied by 4 upon 3, which is an answer of 4 upon 3, or as a mixed number, it's 1 and 1/3. Question 4, we've got 15 upon 4 divided by 5 upon 2. So we keep the first fraction, 15 upon 4, we flip the second one, so that's 2 upon 5, and we multiply. Again, looking for cancelling, the 15 and the 5 cancels to 3 and 1, and the 2 and the 4 cancels to 1 and 2. So our sum simplifies to 3 upon 2 multiplied by 1 upon 1. So 3 upon 2, or as a mixed number, 1 and a half. Again, I must emphasize you can only cancel top and bottom when you are multiplying fractions. You cannot cancel top and bottom when you're dividing the fractions. Be aware of that. Dividing algebraic fractions. So if we're given a upon b divided by c upon d, the format of the solution will be a multiplied by d over b multiplied by c. Example 5. We're given 3 multiplied by x multiplied by y squared, or divided by, in brackets, x plus 1, and that's all divided by y cubed upon 2. So applying the approach on the previous slide, we keep the first fraction, so we've got 3xy squared, or divided by x plus 1. We flip the second one, so that now becomes 2 upon y cubed, and we change the sign, we're multiplying. Again, we look to cancel down where possible, and we can cancel the y squared on the top with the cubed here on the bottom to leave us with y to the power of 1. So simplifying, that becomes 3x over x plus 1 multiplied by 2 over y. So now multiplying the numerators together, we get 6x, and multiplying the denominator together, we get x plus 1 in brackets multiplied by y. Here are some algebraic fractions tutorial questions for you to attempt. Question 1 is a multiplication problem. Question 2 is an addition problem. Don't forget you need a common denominator. Question 3 is a subtraction problem. And it may help to think of the numerators having brackets around them, because you will need the brackets for the solutions. Question 4 is a division problem, so don't forget we have to keep the first fraction, flip the second and change the sign. And question 5 is also a division problem. I encourage you to stop the presentation and attempt these questions, noting that the answers are on the right hand side here. Algebraic fractions continued. Question 6 is an addition problem, so you need a common denominator. I would encourage you to apply brackets to these terms to aid your solution. They need to be in brackets. Question 7 is a subtraction problem, and again I would encourage you to put brackets around these terms to help with your solution. And question 8 is a division problem. Notice it uses the variable of theta here. This is the theta variable. Just think of it like an x, effectively. Answers again shown on the right hand side here in the square brackets. Again, I would encourage you to stop the presentation and attempt these questions. Algebraic fraction tutorial questions continued. Question 9. If p divided by q is equal to 1 divided by 3, we're asked to find the value of p squared plus q squared, all divided by p squared minus q squared. The question does give us a hint. It says to rearrange so that q is equal to 3p from the original expression given, and then substitute the value of q into the p squared plus q squared divided by the p squared minus q squared expression and solve it. You should find the answer is negative 5 upon 4. Similar approach for questions 10 and question 11. In question 12, the difference between a numerator and a denominator of a fraction is 5, and if 5 is added to the denominator, the fraction is decreased by 1 1/4, 1.25. We've got to determine the fraction. To help you solve this problem, I suggest you let the numerator equal to x, denominator equal to y, and then generate two equations based on the parameters given in the question, and substitute one equation into the other equation to solve simultaneously for the answer. The final answer is 2 1/4. Quite a thought-provoking question. Here are some tutorial questions, solutions. I will let you look at them at your own pace. Solution to question 1 and question 2. Solutions to question 3 and question 4. Solution to question 5. Solution to question 6. Solution to question 7. Solution to question 8. Solution to question 9. Solution to question 10. Here's a reference source that helped in the preparation of this presentation. And I hope this has been of help to you. Thanks for viewing.